Write your name and your roll number in the chat box. So remaining part of the green chemistry and nano chemistry we will start. So yesterday we started this chapter. What is mean by green chemistry? What are the 12 principles of green chemistry? Who is the father of green chemistry? That is Paul Anastas, who had given the 12 principles of green chemistry. Then we also discussed the what is mean by nanomaterial, what is nanotechnology, what is nanoscience. So these questions will be asked for board exam for 1 marks. Total weightage of this chapter is only for 4 marks. And this chapter is included in applied chemistry. So for the JEE and NEET exam, remember, no any question will be asked from this chapter. Those students who are preparing for these competitive exams for NEET and JEE, no any question will be asked from this chapter, remember. But for the CET, the questions will be asked. So this dimension part is completed. Yes. I'm going to start again these characteristics, features of nanoparticles. First one is color. Yesterday I explained this color, but I want to explain it again. Nanoparticles having some characteristics, features. One is color. Means by using this color, you can identify whether it is nanoparticle or not. See, color is an optical property that is different at nanoscale. Means color will be changed. Means the compound having the different color at bulk and at nanoscale, the color will be changed. See, this example is given, elemental gold. You know, gold in elemental condition, it is having very nice shining yellow color. All of you know the gold. However, if you had only 100 grams, 100 gold atoms, see, means at a nano level, if you have only 100 gold atoms, these are arranged in a cube, its color will be much more red. See the color. So this is a gold in bulk, and see the gold in C bottle, see the gold in at nanoscale, only 100 gold atoms are there. And see now next characteristics feature of nanoparticle is surface area. So always remember surface area increases when the size of the particle decreases. So this is explained with this help of this diagram. See in this diagram, high surface to volume ratio is very important property of nanoparticles. See, if a bulk material is subdivided into groups, if see in the right hand side there is a yellow colored cube is given. Consider this is a bulk. If a bulk material is subdivided into group of individual nanoparticles, so this is also divided and this is also divided into the nanoparticles. See, the total volume remains same. The volume of this one, the volume of this one, and the volume of this one. Volume remains same, but there is a one important thing is changed. The surface area, sorry, the volumes remain same. Yes, the volumes remain same, but see the surface area is increased here. When the size decreases, its surface area increases. The larger surface area for the same volume, these small particles react much faster. So at the nanoscale, as the particle size is very less, as the particle reactivity is very fast, because more surface area provides the more number of reaction sites. This is the reason. See, more number of reaction sites is there. That's why the chemical reactivity increases And this property of this surface area, it is used in catalytic activity. So what is happen in catalytic activity, we will see in detail, because many times the question will be asked on this. Explain the catalytic activity of nano catalyst. So what is happening due to the increase in surface area with surface area will be increases with the decrease in particle size. Nanomaterial based catalyst shows increased catalytic activity. Means whatever the particles which are at nanoscale, which having the more reactivity. Why this is reactive? Why this reactivity is there? Because more sites are available. See this diagram. Because the more reaction sites are available, the reactivity of the catalyst is increased. We will take some examples also. Usually this is done in heterogeneous catalysis. You know, heterogeneous catalysis means the catalyst and the reaction phases are different. If the catalyst in solid form, then the reactant will be in liquid form, or reactant will be in gaseous form. So this nanoparticles, nano catalyst can be easily separated and can be recycled. That's why nowadays these are used. Example I will give. Palladium, see, PD, it is palladium, then platinum. These metals, nanoparticles used in the hydrogenation reactions. You know, in 11th standard also and in 12th standard also, we learned about these reactions. It is called as catalytic hydrogenation by using nickel also, then platinum also, palladium. So these are the very good examples of nano catalysts. Then titanium dioxide and zinc oxide, these are used in sunscreen lotion. Already I explained. These are the two chemicals which are used in sunscreen lotion. These are used in photocatalysis. That's why these are called as these are photocatalysis. These are used in sunscreen lotion. Remember. Then gold in bulk. Means if gold is in bulk form, it is unreactive, but the same gold particles, gold nanoparticles, if these are at nanoscale, at nanoparticles, these are acts as a very good catalyst for various organic reactions. Then this thermal properties, melting point, this is non-evaluative. You can check your sheet also, and you can check your textbook also. This is a non-evaluative for this year. Remember, thermal properties will not be asked for exam. Then next one is mechanical properties also. This is not for exam. This is a reduced syllabus. Then electrical conductivity, this is also reduced. Then synthesis of nanomaterials, this is also reduced, because this is a quite tough syllabus. That's why this is reduced for this year only. Next year, this will be available for the examination. So if any students are interested in this, how these nanoparticles are prepared, so you can read this. Already I have sent the PPT. So all this synthesis part is reduced, remember. So I will not explain. This Sol gel process is also reduced. Sol gel process, synthesis of nanoparticle. This is not for your board exam for this year, but I have given in details also. So those students who want more information about how the nanoparticles are synthesized, you can go through these slides. And this part is also reduced analysis and characterization of nanomaterials, means how the nanomaterials can be identified with these techniques, name of the techniques and name of the instruments, and the information is given. Also I have given these different instruments which are used to identify. This is scanning electron microscope, this is X-ray diffractometer, then this is a transmission electron microscope, it is called as TEM. Then this is a UV visible spectrometer. So this entire part is non-evaluative for this year due to this COVID situation. Now this history of nanotechnology, this is for your examination. So I'm going to start this history of nanotechnology. The nanotechnology having some history, say, nanomaterials have been produced and used by humans for hundreds of years. Means if nowadays you known about the nanomaterials, but these nanomaterials we are using from the hundred of years, and due to the development in technology, advanced tools and techniques, it has been possible to reveal the information about the nanoscale. So some of the examples I have given here, which indicates from the hundred of years we are using this nanotechnology. See, first example is beautiful ruby red color of some ancient glass paintings. See, beautiful ruby red color of some ancient glass paintings is due to the gold and silver nanoparticles trapped in the glass matrix. See this picture I have shown here purposefully. In this picture, we can see this is a ruby red color. See, this ruby red color, it is due to the gold and silver nanoparticles. These are trapped in the glass matrix. So these are very ancient paintings. If you visited many museums, we can see there. Then second one, the decorative glaze or the metallic film, it is called as the luster, found on some medieval pottery. Now this medieval age means in between 12th and 14th century. So in these 12th and 14th centuries pottery, it is due to the certain spherical metallic nanoparticles. I will show the picture. See, such type of potteries, these are from the 12th and 14th century. If you found some glazing is there, if you found metallic film or glazing, this is due to the spherical metallic nanoparticles. See, means we are using this nanotechnology from the hundred of years. Then next one is a carbon black. You know about this carbon black, it is a nanostructured material. It is used in tires of the cars to increase the life of the tire. Carbon nanotubes. Carbon nanotubes are made up with graphite sheet with nano size diameter, have highest strength. So this is a picture of the carbon black. It is used in it is used in paints also. It is used for the preparation of ink also. Then next one is fumed silica. Fumed silica is also the nanomaterial, which is a component of silicon rubber coatings, then sealants, adhesives. It is also the nanostructured material. See, this is a white colored material. It is a fumed silica. So these already nanomaterials already we are using from many years. So the question will be asked for board exam. It is asked for 2 marks. Write the history of nanotechnology in brief. Such type of questions will be asked. Then next last part of this chapter, I am coming to the last part of the chapter. It is a applications of nanomaterials. Yes. Question will be asked for 2 marks on the application. Some of the applications of the nanoparticles are given below. Number one is where these nanoparticles are used. As these nanoparticles can contribute to the stronger, lighter, cleaner, and smarter surfaces and the systems, they can be used in manufacturing of scratch-proof eyeglasses, then for the transport purpose, then sunscreen, crack-resistant paints, and so on, because of these unique properties of the nanoparticles. Then second use, they are used in electronic devices. For example, magneto resistive random access memory. It is a short form is given MRAM. RAM, you know, all of you. This is a random access memory, but this M indicates it is a magneto resistive random access memory in these devices. The nanoparticles or nanomaterial is used. It also plays the important role in water purifier techniques. So there is a very famous advertisement on the television also. I think the famous actor Madhuri Dixit doing this advertisement. Recently, cost-effective filter materials coated with silver nanoparticles. Yeah, this is a famous advertisement of the Eureka board. Eureka board water purifier. It is with new silver nanotechnology. You can also search on YouTube. You will find this advertisement. But we are not interested in the advertisement. We are interested in water purifier technique. Which technique is used and which nanoparticles are used in the water purifier. This will be asked for exam. So recently, this technology is introduced, or this technology is developed, in which uh, say silver nanoparticles are used. What is this silver nanoparticles, and what are the use of these silver nanoparticles? These silver nanoparticles acts as highly effective bacterial disinfectant. Means these silver nanoparticles removes the bacteria. They also removes this E. coli from the water. E. coli, this is one of the type of bacteria. So this silver nanotechnology. So I think the one mark question will be asked on it, because nobody knows on which part the questions will be asked, and no any questions are available because this is a newly introduced chapter from this year. They may ask the write any 4 applications of nanoparticles for 2 marks, or they can ask which material is used in so water purification techniques. Then what is the full form of this MRAM? So in detailed study is required for the board exam. The next application is self-cleaning materials. Lotus is a good example. You know, all of you know about this lotus. So lotus is having the specific property. Lotus is an example of self-cleaning material. Though the lotus is grows in muddy water, its leaves are always appear clean. So if you see the lotus plant, it grows in muddy water. Means the water is actually the dirty water, muddy water, but you can see its leaves very appear very clean always. Why this is happening? Because the nanotechnology is introduced. Actually, nanotechnology is already there. So nanotechnology, where the nanotechnology is there, I will explain. The plant's leaves are super hydrophobic. See, the leaves of the lotus plants are super hydrophobic. Nanostructures on the lotus leaves. See, on the lotus leaves, nanostructures are there. They repel water, which carries dirt as it rolls up. So this lotus effect nowadays, it is used in self-cleaning windows. Nowadays, this technology is used in windows also. So these are the some applications of nanomaterials. So the 100% question will be asked for 1 mark or 2 marks on these applications. So don't neglect these applications. And then the last part of this chapter is nanoparticles and nanotechnology. What are the advantage of nanoparticles and what are the disadvantage of this nanotechnology? I will explain one by one. Number one, first I will explain the advantages of this nanotechnology or nanoparticles. Uh, there is a great revolution in electronics and computing due to this nanoparticles or nanotechnology. Then in energy sector also, nanotechnology will make the solar power more economical and efficient because they are having the unique properties. In medical field also, manufacturing of smart drugs helps cure faster without side effects. Then curing diseases like diabetes and cancer, this technology we are using. Then the mainly disadvantages is pollution. Pollution caused by the nanotechnology is called the nano pollution. This pollution is, you know, all the pollution is very dangerous for living organisms and environment also. Then second disadvantage of this nanoparticles or technologies, nanoparticles can cause lung damage because the particle size is very small. They can cause lung damage. Number three, the characteristics of nanoparticles that are relevant for health effects. These are due to the size, chemical composition, and shape. So, who, someone started the video. Rajvardhan. Who is Rajvardhan? Please. Yes, so the advantage and disadvantages are completed. So this chapter is completed here. So I want to again give a brief revision of this chapter. Once again, I am coming to the brief revision of this chapter. So this is these are the 12 principles, remember. So no any question will be asked for all the 12 principles. For the board exam, they can ask only one principle or any two principles, or particular they will give the name of the principle. For example, explain the atom economy, write the formula of atom economy. Such type of questions will be asked. So read the question, read the chapter carefully. This is very easy, and what you can say, no any reaction is included. So all the theoretical part is there. So it is very interesting chapter, a newly introduced chapter. It is related to the pollution and which techniques and systems are developed for minimizing the pollution. So one question will be asked on these 12 principles, or they can ask any question. Yes, on this diagram also, yesterday I given one activity for you. We have to check the different materials which are using in our day-to-day life. For example, shampoo bottles, for example, drinking water bottles. Then, for example, we can see shampoo sachet, then food containers. So we have to send this activity on my email or on my WhatsApp. So I will check it. 2 marks question will be asked on nanotechnology, and 1 marks question will be asked on green chemistry, or vice versa. 2 marks question will be asked on green chemistry, and 1 mark question will be asked on this. This is actually with option. It is having 4 marks. So 2 marks for green chemistry and 2 marks for nanochemistry. So this is the distribution of marks. So I'm not wasting my too much time. I'm going to start the new chapter. That is the chapter number 13, amines now. So immediately I will start this chapter. And the notes of amines today I will send to you. Notes of amines, and another chapter is chapter number 8. That is the coordination compounds. Yes. So I want to give the information how many chapters are completed. So be ready. Halogen derivative chapter number 10 is completed. Then alcohol phenol ethers is also completed. Then aldehyde ketones carboxylic acid is completed. Then polymer chemistry chapter number 15 is completed. 16 is completed. Means half of the syllabus is completed now. So today we are going to start the new chapter, amines. Yes, this amines is having 3 marks weightage. Avdut Pokre, switch off your video. So this is again the chapter from organic chemistry, amines. This is a functional group, you know, NH2, RNH2 is the primary amines. Then RNHR, this is secondary amines. Then RNR, 3 R's and 1N is called as tertiary amines, but I will explain in detail. This is again having the 3 marks without option, and with option is 4 marks. Yesterday, one student called me, sir, this weightage is final or this is proposed. So I want to give the clarification about this one. This weightage is 100% same because I have prepared the weightage for the entire Maharashtra for the board exam. So that's why confidently I am giving this weightage to you. Weightage of physics and weightage of chemistry, weightage of biology, weightage of mathematics, weightage of English, Marathi, IT. These weightage are not known to the teachers. So within 2 or 3 days, HSC board will give this weightage. So don't make confusion. All the weightage are same. Whatever the weightage I have given, this will be same for board exam. Next week also I am going to give you the question paper pattern also. Then one model question paper also I will give you. One model answer paper also I will give you. And I will give the unit test pattern. Then I will give semester pattern, which instructions are given for the board exam, how to write the paper. So we will discuss all these parts after completing the syllabus. Yes, what are the amines? I will start first. All of you know the ammonia, it is having the NH3 group. So amines, these are the nitrogen containing compounds, remember. Amines, these are the nitrogen containing compounds. In previous syllabus, the name of the chapter was nitrogen containing compounds. In this chapter, only amines part it is included in the new syllabus, and the nitro part is removed. So it is a good news for you. The chapter is reduced. Only amines part is kept for your examination, and nitro part is not there. So what is this amines? Amines are the nitrogen containing organic compounds having the basic character. Basic character, you know what is meant by acid and what is meant by base. Basic character means these having the pH between 7 to 14. And all these amines are basic in nature because they are having the nitrogen with lone pairs. When this lone pair is given, according to the Lewis theory, the electron pair donors are called as Lewis bases. Further, I will discuss all these points. So remember, all these amines are in basic in nature. Amines are present in many plants also, in animals also. Many natural compounds like proteins contains amines, then vitamins, then hormones, then many plants products like nicotine. Yes, I'm coming to this. Nicotine is very important. This is present in tobacco. This nicotine is present in tobacco, and this is very harmful for health. This nicotine contains amines, remember. So the classification of amines, I mean directly coming to the amines are also classified as a primary amines, secondary amines, tertiary amines. But this classification is depend upon the number of alkyl groups attached to the nitrogen. The classification of amines is quite different than the classification of alcohols and classification of alkyl halides. This is different because the classification of alcohols and alkyl halides is based upon the number of carbons, but this classification is based upon the how many alkyl groups are attached to this NH2. See, actually, these amines are the derivatives of ammonia in which one hydrogen, two hydrogen, all the three hydrogens are replaced with R group. See, in this, only one hydrogen is replaced with R group here. So it is a primary amine, aliphatic primary amine. This is also the primary amine. Primary amine means NH2 group should be there. NH means it is secondary amine, and only N means it is tertiary amine. So this is the classification of amines. I am coming in detail. So in case of primary amines, remember only one hydrogen of ammonia is replaced with R group or AR group. Again, the classification is based upon the aliphatic and aromatic amines, depending upon which group is attached to this NH2. So RNH2 is a primary aliphatic amine. ARNH2 means it is a primary aromatic amine. So see, this is a good example. Aniline is a good example of aromatic amine. C6H5, this is benzene ring and NH2. Further, I will discuss in detail. So you must know the classification of primary, secondary and tertiary amines. This is based upon the number of groups which are attached to the NH2. If one alkyl group is there, it is primary. If the two alkyl groups see there, two alkyl groups are there, it is secondary, and the three alkyl groups are there, it is a tertiary. So again, the secondary and tertiary amines are further classified as a simple or symmetrical amines, like ketones. Like ketones also classified as symmetrical ketones and unsymmetrical ketones. So, and ether also, simple ethers and mixed ethers or unsymmetrical ether. So the classification of the secondary and tertiary amines only, remember, because in secondary and tertiary amines, the more than two alkyl groups are attached. This is not possible to classify because only one R group is there. So again, the secondary and tertiary amines are further classified as simple symmetrical amines and unsymmetrical amines. When all the alkyl groups on the nitrogens are same, it is called a simple amine. See, this is one CH3 group is there, another CH3 group is there. So this is a symmetrical, or it is also called as simple amine. Then if these groups are different, then amine is called as mixed amine. If one is a methyl group and another one is ethyl group, then the amine will be mixed amine. So I will give the example in the next slide in the nomenclature system. Amines are also divided into two major classes. Just I have explained, aliphatic or aromatic amines. And these aliphatic or aromatic amines are depending upon the groups. Depending upon the groups means alkyl groups or aryl groups which are attached to the nitrogen. See what is the primary amine, secondary amine, and tertiary amine in detail. I will explain. See, in primary amine, NH2 group is attached. In secondary amine, this is NH only because there are two R groups. There is only one R group. And in case of tertiary amine, there is only nitrogen. All the hydrogens are replaced with alkyl amine. So these are the examples: ethylamine. All these are common names. Remember, ethylamine. So ethyl group is attached here. So that's why it is ethylamine. Then dimethylamine, because there are two methyl groups. Dimethylamine, this is secondary, and this is a trimethylamine. This is a tertiary amine. If the carbon is tertiary, I want to give the explanation why students get confused in amines and alcohols. If the alcohol is, if the carbon is tertiary and the amine will be primary. For example, one example is given here. See, isopropyl amine. See, isopropyl amine is a primary amine, but isopropyl alcohol is secondary alcohol. See the difference in amines and alcohols. In case of isopropyl alcohol, the carbon is secondary. But in case of isopropyl amine, the NH2, when this NH2 group is attached, the amine become primary. Remember, always when NH2 group is there, always it is a primary amine. When NH is there, it is always secondary amine, and only nitrogen is there, always it is tertiary amine. So don't make confusion in between amines and alcohols. Now I am coming to the common names and IUPAC names. So with this chart, we will get the clarification. First, I will explain what is meant by common names. See, in case of common names of aliphatic amines, we have to write the name of the alkyl group by suffix amine. For example, this alkyl amine, we have to add in suffix, means after the name of the alkyl. In case of mixed amines, the name of the alkyl groups are written in alphabetical order. If the two or three identical alkyl groups are attached, then we have to add this prefix like di, tri, tetra. Then this is a C6H5NH2. This is a very famous aromatic amine. The name is called as aniline. This aniline is also accepted by the IUPAC. So aniline can be considered as common name. Aniline can be considered as IUPAC name. It is also called as benzamine because this is a benzene group and this is a primary amine group. So I am coming to this common name system. See, as the rules of the common names indicate, methyl and this is amine. So this is a methyl group CH3 and this is amine. And Next one, this is a propyl amine. Propyl N-propylamine. This N indicates it is straight chain. N-propylamine. This is because this is N-propyl group. C. 1, 2, 3 carbons are there in the straight chain, and this is a amine. Then this is isopropylamine. You know what is mean by isopropyl group? Second carbon having the CH3. So if this is one carbon, if this is second carbon having one CH3, and amine is attached, so it is a isopropylamine. Then this is a ethylene diamine. See, diamine means two NH2 groups are there. One NH2 group is here and one NH2 group is there. So it is a diamine. When the two amines are there, it is a diamine, ethylene diamine. Then this is allylamine, which in which the double bond is there. So this is allylamine. The aniline, just I explained. This is aromatic amine, aniline. Now I am coming to the IUPAC nomenclature system. See, in case of IUPAC nomenclature system, amines are named by replacing the E of the alkane with the amine, like ethanamine, methanamine, like this. Alkanamine, we are using this word alkanamine. So all the rules are same. Select the longest chain containing nitrogen. All the I'm not explaining in detail. Directly I am coming to this IUPAC nomenclature system. See, uh, the methane CH4 is methane, so E is replaced with amine. So this is a methanamine. See, methanamine. If the C2H5 group will be there, it will be ethanamine. Then there is a propane 1 amine. Why this one indicates? This one indicates that the propane 1 amine means, see, I will give the difference between propane 1 amine and propane 2 amine. On the carbon number 1, if the amine is attached, so this is propane 1 amine, and see in the second example, see, this is the longest chain, 1, 2, 3. On the second carbon, NH2 group is there, that's why it is propane 2 amine. This 1 and 2 indicates the position of NH2, on which carbon the NH2 is attached. So with these two example, it is clearly seen. This is the propane 1 amine. Propane, why it is propane? Because there are 3 carbons, 1, 2, 3. Actually, this is 1, 2, 3 because NH2 is attached on the first carbon. And here NH2 is attached on the second carbon. If it is 1, 2, 3, this NH2 is attached on the second carbon. So it is propane 2 amine. Now I am coming to these 2 amines. Ethane. Why it is ethane? Because there are 2 carbons are there, 1 and 2. Ethane 1, 2. So this 1, 2 position indicates on the carbon number 1 and on the carbon number 2, diamine group is there. Diamine means, you know, this NH2, 2 NH2 groups are there. One NH2 is on carbon number 1 and another NH2 is on carbon number 2. And this is a prop 2 in. So in indicates double bond is there on the second carbon, and 1 amine indicates on the first carbon NH2 group is there. So again we are coming to this one, prop 2 in, always see, this is carbon number 1, this is carbon number 2, because the NH2 group attached to carbon, this is considered as carbon number 1. So this is carbon number 1, carbon number 2, and 3 carbons are there in the longest chain. On the carbon number 1, NH2 group is there, that's why it is 1 amine. And on the second carbon, double bond is there, that's why the name is prop. Prop indicates 3 carbons. 2 in indicates on the second carbon there is a double bond, and 1 amine indicates on the first carbon there is a NH2 group. So this is a NH2, and this is benzene ring. This is a parent aromatic amine. So this aniline is a parent aromatic amine. When the NH2 group is attached to the benzene, it is called as aniline. So this aniline name is also accepted by the IUPAC, or it is also called as benzenamine. Why it is benzenamine? Because